Okay, so question 8 asks us to write the inequality that's represented in each graph. There's two of them, part A and B. Both of these have a boundary condition. It's kind of hard to see maybe on the screen, but if I zoom in, you can see the boundary condition for A is a dashed line. That means that these points that are on the line are not included in the solution, but this is still the boundary line. It tells us where our solutions begin. Anything that's above this line, you can see, is shown to be a solution because it's shaded in. So all of these points would work, and even the ones that are off in the middle, I can't exactly tell what the coordinates are, would work. And anything below this line would not be a solution, including the origin. This is not a solution for this particular inequality. So whatever the boundary line is, it is certainly, y's are certainly those things that are greater than the boundary line. And then we just get to what is this boundary line? Well, there's two values we can see, right? One of them is our y-intercept, and the y-intercept for this is clearly at the point positive 4. So we know one of our two parameters. And the other parameter is the slope of this line. And you can see the slope is down 1 and over 1, 2, and 3. So the slope here is negative 1/3. So if I write the inequality, right, y's are greater than negative 1/3 x, that's our slope pattern, and then plus our y-intercept of 4. So what you see on the right hand side there, negative 1/3 x plus 4, is the boundary line, and the y's are strictly those things that are above that line. Let's look at part B. Pretty similar. The difference here, though, is this time our boundary line is solid, and you'll notice that we're shading below this boundary line. So since we're shading below this line, right, we are looking at, again, these are solutions and this is not. We're looking at those points that are y values that are less than or equal to. I've added the or equal to because you can see the boundary line is a solid line. It's not dashed like it was in the previous problem. So what is the boundary line? Well, we can still see here our y-intercept is at 2. That's quite nice. And our slope pattern is up 3 over 1, right? I have a rise of 3 and a run of 1. Or I could also say that I have, for example, a rise of 1, 2, 3, 4, 5, 6 and a run of 2. But in either case, 3 divided by 1 or 6 divided by 2 is still a slope of 3. So y's are those things that are less than or equal to 3x and then plus the number 2. So that is the solution that we see here. This inequality that I've written indicates all of the points in the shaded region.